All right. Good evening, everyone. It is the top of the hour. Welcome to the Global Math Department. My name is Lee Natero, and I'll be your host. Tonight, we're going to be hearing from Ed Nolan on getting the best from questioning strategies in mathematics. Before we begin our session, I'd like to tell you a bit more about the Global Math Department. The Global Math Department is an organization that is run entirely by volunteers. To keep the free, high-quality PD, we need webinar speakers, webinar hosts, and writers for our newsletter. Newsletter writers share about an area of math or math teaching that resonates with them or discusses recent math blogs to help teachers reflect on their practice. If you would like to volunteer or know someone who would be great in any of these areas, please have them email us at globalmathdepartment@gmail.com, or they can reach out to us on Twitter. Before we get started with our session tonight, let me explain about how our webinars work. Our webinars are recorded and are available about 24 hours after the meeting ends. To view the recording, you can use the same link you used to get here tonight. The Global Math Department community prides itself on being friendly and supportive. The chat room is available for topical and general conversation throughout the meeting. And if the chatter gets busy, I'll be sure to catch your questions for the presenter to be addressed at the end of the presentation. If you haven't already done so, please take a moment to introduce yourself in the chat, telling us what you teach, where you teach, and what your Twitter handle is, if you have one. And I see Juan Paulo from the Philippines. He's often a frequent attendee of these meetings, and I recognize some other names in the list of attendees as well. So go ahead and introduce yourself in the chat. Our webinar speaker for tonight is Ed Nolan, and he will be sharing on the topic, getting the best from your questioning strategies in mathematics. Edward C. Nolan is an assistant professor of mathematics education at Moravian University. He has taught middle and high school mathematics for 19 years, served as an instructional coach and district supervisor, and provides professional development to K-12 teachers across North America. In 2005, he won the Presidential Award for Excellence in Mathematics and Science Teaching for secondary mathematics. His research interests lie in making sense of mathematics for teachers, both pre-service and in-service, through what they notice and how they respond to it, with a focus on questioning. And now I'm going to turn the presentation over to Ed.
Why, thank you. I appreciate that, Lee. And so as you can see, I've got my Twitter handle up there as well. So if you would like to follow me on Twitter, that's who I am. I've also got my email up there. So if questions come up after our session and you'd like to ask, you're more than welcome to. I see some folks are introducing themselves. It's amazing. It's great to have such a worldwide presence. This is really special, and I appreciate everyone who's here tonight, and hope that we can have a really informative and valuable session for you. So as you're getting used to the chat box, I have a few questions that I'd like to ask based on the topic that we have today. And so one of the things I like to start off with is, so why do you think teachers ask questions? So in the chat box, type in, what do you think the purposes of questions are? Why do teachers ask questions? Okay, so we have to generate student talk, to see what students understand or maybe what they don't understand, to explore prior knowledge, to know if students already know the answers, insight into what students are thinking, and to encourage thinking. Those are all great purposes for questions, to gain understanding about student knowledge. All of these, and I love that you've really captured what I truly find valuable about questions, because I think teaching is one of those rare instances, somewhat like being a lawyer, where we ask the questions and we already know the answers, right? We're trying to figure out, do our students know those answers? What do our students understand? And it's intriguing because, and you can see it there, and some questions are better than others and have different purposes, which is going to be actually where we go next. But I'm going to hold on to that question because we also ask questions for a lot of different purposes, because we ask questions to try to gain engagement from our students. We ask questions to move our own lesson along. We ask questions for a lot of different purposes. And so you guys gave me those great esoteric, really big ideas about trying to learn, our formative assessment questions. But we also ask a lot of lower level questions and a lot of pacing questions and a lot of different things. And so in tying back into, so some questions are really effective, maybe some questions aren't so effective. What makes a question effective? What differentiates effective questions from non-effective questions? So, and I've done this, and while you're thinking about that, I'll talk a little bit about, I've videotaped myself a number of times teaching and then gone back and watched it. And for me, that's been one of the best professional development experiences, is evaluating my own teaching as opposed to watching somebody else teach or reading about somebody else teach. It's watching myself and then think, is that the best question I could have asked, or was there something different? And to try to take away that I'm managing the classroom at the moment effect and try to think about just about my questioning. What makes a question effective? What makes a question not as effective as I would like? And so in the chat box, what makes a question effective? Effective questions elicit more than a 1-word or 2-word response. I've really tried to get away from those yes/no questions and ask more how and why questions and fewer can you type questions, because I really want to get at the explanations behind thinking. Melissa talks about the question that requires higher order thinking. And that's an excellent, excellent point. It can be answered in more than one way. Joe, that's a really important point in thinking about the kinds of tasks we ask, the kinds of tasks we use, in addition to what we're trying to promote with our questioning, is we want to have the students to still have choices about how they respond to our questions. We need to make sure that our questions have more than one response, not just a right and a wrong, but maybe a couple of different ways it might be right. And that's why you can think about that more than 1 or 2-word response. Maybe it's the explanation that makes it different. Maybe it's the justification that makes it different. Nicholas talks about we need students to think deeply about these topics. Melissa, that many different entry points, right? That low floor, high ceiling. I want to be able to capture all of my students in this question, because my students are coming from all kinds of different backgrounds, and they have different knowledges. They have different experiences and different backgrounds. And how am I using my questioning to really get at their understanding? And so I can learn more about them, and I can promote that positive identity where everybody's able to come up with an answer to the questions. Cindy talks about helps a teacher determine where students are in their learning and serves as an indication of where to go next. So it's, and there's a lot of information in that, as well as thinking about even how you might think about how you organize your questions. One way to organize them could be assessing and advancing questions. And Cindy kind of captures both. Assessing, we get to find out what our students know, and then advancing, we get to try to think about where do I want to push them next. If I know they've got my learning goal, where am I going to extend them? Where are we going next? Excellent points. Excellent points. And so one last thing about is, so we talked about why we ask questions. We talked about what makes one effective. How do we build that effective question? How do we learn how to do that? What do you think? In your experiences, practice, Cindy, that's great because you're going to get that opportunity today. So I love that you think that way. So practice is one way. How else might we be able to help ourselves build good questions, effective questions? Everybody agrees with Cindy. Practice. Write questions down prior to the lesson. So that's one of the other things we're going to talk about is planning, right? It's not just practicing it, but sometimes it's actually planning it. And an opportunity here is we get to plan together. We get to think about, Joe, You got my strategy down. Steal them from good sources. That's really important. That's learning from each other, right? In classroom, it's called cheating. In the real world, it's called collaboration. We're absolutely going to work together to try to get better. Melissa, this idea of writing questions, when we think about it, we also have to think about how we think students are going to respond, because we might even be able to map out some flow charts about how students respond, how we think they're going to answer, and then what we're going to do when we get to that. I always talk with my pre-service, and when I coach in-service teachers, I'm always talking about my lesson plans always had that I knew my students were going to make this error. What I forgot to do is then say, but what am I going to do when I see it? And so it's that idea of we have to anticipate the response, but we also have to anticipate our responses when we hear some of these things. And as Cindy says, there are resources on the web. Yeah, a couple billion of them. How do we narrow that down to get to those things that are effective? So let's roll into where we're going to go. So I love to do math. So we're going to start with the math problem. So I'm going to read the math problem to you, then I'm going to let you have some time to think about it. So Susie had 1/4 of a pan of brownies. She ate 3/4 of what she had. How much of the original pan of brownies did Susie eat? So I'm going to let you think about that. I'm going to shut up for a few minutes. I'm going to let you think, and then I'm going to come back just a little bit. Okay, that's long enough. So now what we're going to look at is we're going to think about what we're going to get. Let me tell you the outline of our session here. So we're going to talk about strategies for planning effective questions. We're going to discuss how those questions help meet the needs of your students. And we're going to link these ideas to positive visions of learning. So we're going to work on a couple of problems. We're going to talk about how we would plan and what we think might happen. Then we're going to watch videos of students doing these problems. And then we're going to come back together and say, so what did we learn? What did we anticipate well? What did we overwork on? Do all those kinds of things. So, and we're going to embed this in what we call the TQE process. So as you can see on each one of my slides, I have covers of books on the left-hand side. Those covers are for K2, 3, 5, 6, 8, and high school. And you heard Joe talk about he likes to steal from different people. Those are sources. And so the problems we're doing today, one of the problems is from the 3-5 book, and one of the problems is from the grade 6-8 book. And these books include QR codes and URLs that go to videos that talk about it. So the entire thing that we're going to see today, that's a source of information you can use. And so when we talk about the TQE process, we're going to talk about the task that is selected. And so we've seen one of those because that's what you just worked on. We're going to talk about productive questioning so that students can engage in those mathematical practices that we know are so important to get at that deeper critical thinking that we said that questioning is really built around. And then we're going to collect and use student evidence. How is that evidence guiding what happens next? Right? Because you talked about, well, we want to use questions to figure out what the students know and what to do next. That's that student evidence. And that's where that questioning and evidence loops together to figure out how well our students are making sense of the learning goal. So as we think about this, let's go back to our problem. In the chat box, if you have it, type in what you got as your answer to this problem. How much of the original pan of brownies did Susie eat? Okay, so I see a few answers going up there, and now there's going to be a ton of peer pressure to see if anyone has a different answer or if everyone has the answer the same as the ones that are up here. So I see a lot of different answers. So now that I see a lot of the same answer, my question is going to be to you, so what do you think students might have done that wouldn't have gotten that same answer, right? So everyone up there has 3/16 or 3/16. What do you think students might get as an incorrect answer? What might they do that isn't that same answer as everybody got? And before we go there, I want to talk about what this problem was set up as. So one of the things we do with our students is we have them make a fraction kit. And so everybody gets 6 sheets of construction paper. 2 sheets of red, a sheet of blue, a sheet of yellow, orange, and green. And then we have them rip them. So they take their blue construction paper and they fold it in half and they rip it. So they have 2 equal pieces. And then orange, we split into fourths. Green or yellow, we split into eighths. And green, we split into sixteenths. And what this allows us to be able to do is we can now model problems like the one you have in front of you. So we start off with these 5 different colors. 2 of them are red. We take the blue and split them in half, the orange and split them into fourths, the yellow and fold and rip. And we have the students physically fold and rip, not cut with scissors, but fold and rip. And in the folding, you really get to reinforce that those 2 blue pieces are the same size. And the 2 blue pieces fit over the red piece. So you can see how blue is 1/2 of the red. We go through a lot of different tasks and we change the whole. And we say, okay, so if I had the blue as the whole, how much of the blue is 1 piece of the orange? We go through a lot of those different relationships. And so when we would start a problem like this, we'd say, okay, so I might say that the red would represent my pan of brownies. And if you remember back to the problem, our pan of brownies, you know what I forgot to do? I had not given us the handout. Hold on, let me do that real quick. I'm going to put a Dropbox link in the chat box. That link is to the handout for our session. And so you'll have many of the slides in there that we are talking about in this workshop. And now, so we start with the red. We said if the red is the pan of brownies, now we say, okay, so Susie had 1/4 of a pan of brownies. How would you model that? And so we take the red and we show 1 orange and we put 1 orange on top of the red. And so it would look like this. And then we say, okay, so now how would you model this next? She ate 3/4 of what she had. And so students will think about that. Megan, great question. What grade level is this with? This is let me make sure of this. This is a 4th grade task. Pretty sure it's a 4th grade task. Nope, I lied. This is a 5th grade task. I'm glad I looked. Megan asked, what grade level is this? This is a 5th grade task. And so modeling the task, we've got 1/4. We'd ask students then, so if that's 1/4 and Susie ate 3/4 of what you had, how would you model that? And we'd expect this. And as many of you have identified, that would be 3/16 of the original pan of brownies. Now we have to think about, okay, so we picked this task. What learning goal are we looking at? So in the chat box, what do you think the learning goal is here? And as Megan asked, we know this is a 5th grade task. What do we think the learning goal might be? Students can multiply fractions, multiply with fractions. Understanding fractions represented related to the whole, either multiplication or division of fractions. To picture the problem, that's an important part. That's part of this. And Jonathan David, I really like that idea of the representation, right? That mathematical practice of, can I picture what's going on? I mean, that big comprehension part that holds back a lot of our students. Cindy, demonstrating an understanding of equivalencies. Excellent, excellent. Trish talks about fraction of a fraction, modeling, fractionally. You can see there's so much embedded. There's so much mathematics embedded in this one task. So what I put together, I thought of this as solving real world problems involving multiplication of fractions by using visual model fractions or equations to represent the problem. And so I really wanted, and that's one of the reasons why we make that fraction kit, is I don't want students just pulling fractions out of a problem and writing an equation. I want them to make that visual. I want them to make sense of the real world problems. And as you heard in the bio, I'm really big on making sense of mathematics, both for teaching and for learning. And so for my students, I really want them to make visual representations. And so let's talk about what solutions do you think might happen? So you saw the model that I created, and it's actually the model that you're going to see in the video we're going to watch in a short bit of time. What student errors do you think are possible? What do you think students might respond? How might they interpret this differently? What do you think they're going to look for? that might not quite be what you want. So in the chat, we know one of those answers is 3/16. What other answers do you think might students get? And let me go back. I don't have it here. No, I'm not. Okay. So Megan says 3/8. Takeaways. So some students might say 2/4 of taking the 3/4 minus the 1/4. Not making equal pieces. So maybe getting 1/5. Without the paper fraction, students might try 3/4 and again getting the 2/4. Some students might get 1. Interesting. So let me keep track of all of these great answers that we have. So we have 3/16 as one of our answers. Let's not forget to keep that one in there. We have 3/8. We have 2/4. We have 1/5. I think on that same line, as I look at the picture, I think they might also get 3/5 for a very similar reason, right? The pieces that we have eaten as 3/5. I have 4/4, and I'll put that as equal to 1. Knowing students often reason, I would expect the solutions above. So, and so that's one of the big reasons why that visual representation is such an important element of what we want our students to do. So now what I want you to, and so I have a couple others. Let me show you some of the other ones that I was thinking of. I thought about 1/4, this section, right? If they completely forget that this is a red rectangle represents the pan of brownies, instead, if they just see that one little orange piece, they might say, okay, well, that's 1/4. And by same comments, they might pick 1/16 because they might see the yellow is 1/16 of the whole pan. And then they might say 3/4, again, thinking just of the 1/4 that was remaining, she ate 3/4, and then we have 3/16. So what I'd like you to do is pick one of these incorrect solutions, right? We know 3/16 is the right solution. So pick one of these wrong solutions and think about if you were walking around the room and saw one of these solutions, what questions might you ask? What question would you ask? One question would you ask. So pick one of these solutions and write a question you would ask tied to that solution. Pick one of these solutions. And so in the chat box, first type what solution you're picking, and then what question would you ask if you saw a student had an incorrect solution? What question would you ask of that particular respondent? And I'm not even going to complain that it's not a question. Tell me more, right? And I think that's tell me about your answer. Tell me more. Did you eat more than 1/2? So looking at the answer and then kind of a reasonableness kind of question. And asking questions around, does that answer make sense, right? What made you think the answer is what you got? What color are you representing in the 3/4? Who agrees with? So Megan's looking at this as either a small group kind of discussion or a whole group kind of discussion. Can you convince me? That's an interesting proposal, right? Because now all of a sudden we've moved into the explanation stage. All of these are really getting at the how does this make sense? Maybe, and I can see here, maybe you tie back to the representation, asking them to link their answer to the representation they've drawn. Asking again, digging into the context of the question. How many of you have problems with students with their literacy skills and they are challenged by word problems because they're challenged by the reading? Those are really important points. That's one of the reasons why we read the problems together first, because I want us to move away from the literacy being an inhibitor. I want to try to knock down that barrier by reading it together. How do you know? What part did the student eat? Tying back again, how am I using what they have? What evidence do I see in front of me? And how can I use that evidence to help my students think? Because I don't want to tell them their answer's wrong. I want them to figure it out themselves. Because the more that they do themselves, the more they're building that positive identity of they can do this learning. And I only reinforce that by how I help them see that. Okay. So as we've done some planning, right? We've done a task. We've thought about ways that students might get it wrong. And we've thought about how would we ask them? What questions might we ask them to get the different solutions, right? We've done some general, how do you know? But then we've also gotten into specifics. And that's really important for you to think about. How am I getting into the specifics of those kinds of questions? So teachers who have a deep understanding of their content facilitate targeted and productive questioning strategies because they have a clear sense of how the content progresses. So this sense of what do they know about fractions? Because that's a big part of that, right? We talked about that when we talked about the task. We need to know about equivalent fractions. We need to know about modeling fractions. How do I know about, and I don't care at this point in this discussion specifically, I'm not looking for them to write an equation and use an algorithm to solve the problem. That's not what my focus is on this task. My focus is on this task is making sense of it, representing it, and making sure that they come back to represent part of the whole, not part of the part. And that's a really important element of this type. And so when I thought about this, because you're going to watch me teach the grade 5 class, you're going to see them in the classroom with this task. And so these are some of the things that I thought about as questions. How do you identify fractions you're using in your picture, in your diagram? Questions that you came up. How much is eaten? How much is left? What are you measuring? What are you answering? Tying back into that task. What operation is being modeled could be a way to continue how that could work. So what we're going to do is we're going to look at this as a video. Okay. So what I want you to think about is, do you hear the questions that you were thinking of? And how do your plan questions, maybe how you might see or think about things differently based on the planning that we've done. So let me come down and I'm going to open this up. Okay, I see. Okay, I'm going to ignore that. First off, did you hear the sound of the video? Okay, just making sure. Thank you.
Class, we've been working with fractions, and today we're going to work with a problem looking at how to make sense of fractions. Susie had 1/4 of a pan of brownies. She ate 3/4 of what she had. How much of the original pan of brownies did Susie eat? What do you start with in this problem? Yes.
We start with 1/4.
Why do we start with 1/4?
Because in the problem we said Susie had 1/4 of pan of brownies.
So let's think about what we're starting with. What does this represent? Yes.
A whole.
So in our problem, what does this represent?
A pan of brownies.
So this is our pan of brownies. What does this represent? What's the orange in my pan of brownies? Yes.
1/4 of the pan of the brownies.
What happens next in the story? Yes.
She ate 3/4 of what she had.
So how are we going to take 3/4 of the pieces when we only have one piece? Talk at your tables about it. So how are you using your fraction kit to help you make sense of this. So you have one orange piece. How is that helping you think about this?
She ate 3 pieces of the 1/4 of the ground.
Do you agree with what he said about the pan of brownies?
Yes.
So what do your 3 green rectangles represent?
How much she ate?
Got it. Thanks. Can I have your attention back, guys? So what did you talk about? How much did Susie eat? Yes.
She divided them with the 16ths. She had them like this. And she took away, she ate 3, and she had one more left, 1/16 left.
So how much did she eat?
She ate 3/16.
What did he say? Yes.
Susie had 1/4 of a pan of brownies, and she ate 3/4 from it. And
Would you like to help her?
the green one represents the 16th, the 3/16 that she ate.
The 3/16 of what did she eat?
The pan of brownies.
Does that make sense to you now?
Yes.
So how much did she eat?
3/16 of the brownies.
And how do you know that?
It's because she had 1/4 of the pan of brownies, and she ate 3/4 of what she had.
And that ends up being
3/16 of the pan of the brownies.
nice work. I really appreciate your thinking on this one. What we've looked at today is using our fraction kits is how to model fraction operations in word problems and how to make sense of them using a model. Thank you. A model. Thank you.
Okay, so what did you notice either about the video itself, some of the things that went on in the video, or the questioning in the video? Students had time to talk to each other. A lot of repetition, not just by you, but by the students. Students took risks. Empowering students to help each other, collaboration amongst the students. Were these students prepped? I can get into that. I was there. Developed a problem with the whole class. So we talked about that. How do I make sure that I wanted the students to make sure they understood the problem? So I read the problem. We asked questions about it before they get started. You're noting here more than one student responding. There's collaboration. And so Megan asked about the context. Were these students prepped? This was the first day that we did recording. I had not met these students before. About 3 minutes before we started to roll cameras, we talked about what we were looking for. And we have 3 norms that we say. It's when you respond, I don't want just your answer, but I want explanations and justifications. I want to hear your thinking. I want you to try to make sense of anything you hear, whether it's from the teacher or another student. You really need to work on making sense of it yourself. And that third rule is if you're not sure what's going on or you have a question, it's your responsibility to ask it. That's all the prep that occurred. And then we started by giving them the problem. And you saw me do a bit more modeling with the fraction kit because they did not make those fraction kits. I brought those fraction kits with me and handed them to the students. So they hadn't used them before. So there was a little bit more questioning involved with the task because I wanted them to model using the fraction kit. So we talked a little bit more about the fraction kit. Students referred to fraction models to support their explanations. Students really had to explain what they were thinking. That was, again, as you have that norm, if this is a classroom norm, the actions you take as a teacher need to support that that's what you agree to. That's what's important to you, and you emphasize that in the types of question that you ask. Emphasis of units, connecting to that real life example that we need it, because that labeling of that answer is very important, because 3/4 could be the answer if they said 3/4 of the leftover brownie instead of focusing on the 3/16 of the pan of brownies. That's why Tritz's comment about units is really important, because of the focus on going back to the whole, right? Because it's the whole pan of brownies, 1/4 pan of brownies, 3/4 of what was left. But now we have to go back and repeat and put that in context of that whole pan of brownies. Megan talks about she liked focusing on invoking the community of learners. Do you agree? Can you support? Why? Those are part of that making sense. It also helps with the engagement, because now students really understand it is their responsibility to listen to their peers and figure out whether or not they agree or disagree and why. Those are really important elements of what creates that effective questioning in your classrooms. Okay, so these are some of the questions that I've pulled out from the video. How are we going to take 3/4 of the pieces when we only have one piece? You have one orange piece. How is that helping you think about this? And how much did she eat? And how do you know? And so these are questions that parallel the kind of questions I was thinking about when I thought about it, when I was planning for it, but they're adapted a little bit because of the conversation that's going on in the classroom. That's a really important element. I need to take the time to listen to my students and what they're saying. And so with that TQE process, I picked a task that was really about making sense of multiplication in context, but also it's coming back to that describing the fraction, describing the 3/16 of the entire pan of brownies. But I also anticipated some of the student errors, so I was looking for them. So I anticipated them, and I thought about what Juan Paulo calls the art of questioning, right? I planned that out so that I was really focusing in on that, so that I could pull out mathematical understandings as well as perhaps common errors. And then using that evidence, listening to what my students are saying, but really using the students to provide responses, not giving them to students from the teacher. It's that community of learners where students are learning to rely on each other as sources of information, as places they can go when they're wondering what to do. And so when we look at, from the teacher perspective, the act of planning and then implementing, and then as we're doing here, reflecting on our instruction, we can think of two different ways teachers might present questions. One of them's a funneling questioning structure, and another one's a focusing questioning structure. And when you look at these, there are some differences. When teachers use questioning to lead students to a solution, so let's say I knew in my head that I wanted all of my students to have 3/16. I might ask questions that instead of opening up the pot, I might narrow it down. I might bring them down and funnel them to the solution and strategy I want them to use. It's narrowing it down, but it's guiding my students to use the strategy that I think is going to help them. In this case, students have less opportunity to make sense of it themselves. And oftentimes they're confused because the way they might make sense of it is not the way the teacher has made sense of it. And it narrows and they get lost. They're not sure what's going on because they're not picturing it anymore, because it's not what they were seeing. In contrast to that, when student thinking is honored and the teachers listen to those contributions and they ask students for the student explanation, they're focusing in on what they're hearing from the students. Students have the space to share their own ideas, to build their own understanding, but it makes it a lot more difficult for the teacher, because now the teacher is not sharing what they've planned. Instead, or in addition to, they're listening very carefully to make sure that they're tying to what the student is saying and making sense of what the student is saying. And so while the focusing is wonderful because it's more guided by what students are doing, it's also a little bit more challenging for the teacher, because you still want to get your learning goal in. You have to think about how you're going to be creating those towards where you want to end up. And so Juan Pablo talked about, I think a lot of teachers are using funneling And I think part of the challenge is, we all have a limited amount of time and we all want to accomplish everything. And so we're trying to figure out how to do that best. And I think if we think back to some of those original comments, it's about time. We have to give our students the time to make sense of it themselves, because when they do that, they are, as Megan says, they're empowered. They become the creators of their mathematical understanding and they own it. They get the identity as a learner of mathematics instead of a listener of mathematics. That's really important for all of us to share in our own roles, whatever we do. We have to think about, how am I building my students' identity as a mathematical learner? How am I helping them see that? And so with that, let's do another example. So what we're going to do this time is, the learning goal is going to be finding percent of a quantity as a rate per 100. Solving problems, finding the whole, given a part, and the percent. So, and we're going to do that with this task. How many students are in a class if 75% of the students is 24 or 24? So what I'd like you to do first, as we always do, let's start by solving the task. I'll be quiet for a minute, solve the task. What do you think is the answer? How many students are in the class if 75% of the students are 24? Okay, I see some answers going up there, and you know where I'm going to go next. So what errors do you think you might see in a task like this? Okay, so I saw a lot of 32s. I see a lot of 18s, right? Which is how this task is set up for that, right? The numbers are friendly. And so if 32 is the part, or excuse me, if 24 and 75%, right? Those are our two key values. And so if they take 24 as the part, then 32 is the whole. If they take 24 as the whole, then 18 is the part. And so you're seeing how these numbers are connected. Does anybody want to say, why don't we take this? So let's go with 18. You're walking around the room, you see some students have drawn some models, and you see that they've written in 18. What question would you ask? Now that we've done this, we've modeled a little bit. What questions would you ask of a student if you see that they got 18? How did you figure that out? So asking for their reasoning. What was your strategy? How do you know? How did you solve that? Does everyone in the group agree? Joe, I love that you're getting back to that collaboration and getting other students engaged. How does 75% compare to the whole? So drawing back to the task. Show me in a picture if they didn't already draw a picture. Tricia, great. Are you sure? And maybe even trying to combine Megan and Joe's together. How could you convince someone else in your group if they have a different answer? Or find two students in the group that have a different answer and say, so one of you needs to figure out how to convince the other. Is 24 the whole of the part? So those are all questions we have to think about. How am I giving students opportunities to respond and have multiple ways of thinking? Very good. Very good. Okay. So thinking about this. So we've looked at our task. So what we're going to do now is what questions would you ask? We've done that. What answers do you expect? Right? So here are some of the questions that I thought up when I wrote this lesson. How do you draw a picture that shows 75%? Because for me, I really want students to model their way of thinking. I want to see those pictures. What are they thinking about in their head? And I can't get that unless I have these questions, or I tell them up front, I want you to draw a picture to show me what your thinking is. Are there other ways to express 75%? Because I want to see, are students connecting 75% with 3/4, right? Because that's part of what might make this task different. Is if they only use 75%, it might be different if they see it as 3/4. And then, and a number of you have talked about show me in a picture, or show me, or how did you solve it, drawing them to that picture that they've drawn. What does, and Megan talks about, what does 75% mean? How can you determine the total number, which I think to me is getting into that what strategy did you use, how did you solve it kind of questions that you're asking in the chat. If they get an answer 18, we can ask them how it compares, the 24 compares to the 18. All of these are really great questions because, again, you're using the context to help you make sense of the task. And so we're going to watch a video. This one is from the middle school book. And so, again, it's going to be, these students have been brought in. This is a 6th grade class. They've been brought in. We've talked about just those initial 3 ideas about explaining your answer. Your job is to make sense of what's going on, and your job is to ask questions if you're not sure what's going on. So let's watch this video and then see where we go with our discussion.
Today, class, we're going to be looking at percents, connecting percents to fractions, and also looking at some visual models for fractions. So here's our task. How many students are in a class if 75% of the students are 24? So I'd like you to work on that problem in your small groups to think about how you can draw a picture to represent your solution. So what are you guys thinking about?
No, since it's 71%, 3/4 is 70% as a fraction.
So how do you think you can use 24 in this picture?
You can use 24 because it says that 75% of the students are 24, and then he shades in four of the little squares in the circle, and that represents 75%.
So you said 24 is the same as the shaded part or the whole part?
The shaded part.
So how many pieces would the 24 be the same as?
3 parts.
3 of the 4 pieces. So how can I use knowing 3 of those pieces are the same as 24? What do you think what's the size of the whole class?
100%.
It's 100%. How many students are in the class?
There are...
Do you have any thoughts about how many students are in the class?
I think about 32.
And how did you determine 32?
Since it's 24, I tried to divide it by 3 and get 8.
Why did you divide by 3?
Because I'm 3/4.
Do you understand why you divided by 3?
Yes, because 3/4, and there's only 3 like boxes that were circled, and then you add the whole to it.
Thank you. So what are you guys thinking about? How'd you get 32?
Because we figured that if we divided 24 by 3, we'd find a number that's 1/4 of the number. So we started with 8, then we added 8 more, so we got 16. Then 75% was 24, and so we figured 100% must be 32.
We multiply it 4 times because it's 1/4, and to get it to the 4 out of 4, which is the whole, we needed to do it 4 more times.
4 times total. Great, nice work. Okay, class, if I can get you back. So how did using drawings help you make sense of this problem? Yes.
Using drawings helps us because we could see a better visual of what the problem is asking.
Thanks. Today, class, we were able to look at a percent, connect that percent to a fraction, draw a model of the connection between the fraction and the percent, and make sense of a finding the whole when we know a part of a class. Thank you very much.
So, what did you notice in this video? And so Melissa's already gotten ahead of me. She'd be thrilled if her students used a bar similar to the circle discussed above, and that the double number line and different representations. Because Melissa, I think it is so wonderful to see students drawing these pictures and making sense of connecting 75% to 3/4, drawing a picture of 3/4, and then thinking about how to split that 24 up so that it balances out across the three pieces. And then what do I have to fill the fourth piece in? Just amazing how well they modeled, and so many different, you saw squares, rectangles, circles, tick marks, all kinds of different representations. And none of that was coached. All of that was just, they were given a whiteboard marker and eraser and they could do what they want. And so it's really important for them to be able to have that freedom to make whatever model they wanted. And I really learned a great deal about their thinking and being able to do that. A lot of students, Tricia talks about this multiplication as repeated addition. You could really see a lot of those students were doing the 8 + 8 + 8 + 8, which you might think, but I want them to use more efficient strategies. I really want them to show me how they're making sense of it. It's not about efficiency in a learning goal and activity like this. It's about what I'm learning as the teacher about how my students are thinking. What I often do in my own classrooms is I carry a seating chart around and I'm constantly taking notes about how I'm noticing, not about what answers they're getting, but what strategies they're using and how are they making sense of the task. Because those are things that are really important to me. And those are things that when I have parent conferences, I always talk about the strategies that their children use and about how they're developing their understanding of conceptual mathematics. Love the synthesizing at the end. And what we know from all of the research that we look at is the importance, those last 5 minutes are the most important time in our lesson. How are we using them to make sure that those amazing things that we've done in our lesson get synthesized and connected in our students' heads so we don't lose them, because it's a really important element. You gave the first student time to think and reply, but when she got stuck, you went to the second student. I thought, Ed, you ignored her. But then you come back and get them to talk to each other. And that's that. How am I building that collaboration in the small group? Because what I'm trying to facilitate is to have that conversation without the teacher having to be there. And those are the pieces that you've talked about in your learning community and so many of these contributions in here of how are we doing that? Well, part of it is how is our questioning drawing the students together and getting them to think about these things together. And so some of the key questions that I saw that were asked is, that identifying where the 24 comes from, identifying and linking the representations, the pieces to the 24, where's the whole class represented? So all of those are pieces about how we're using our questioning to really get at holding the students accountable and responsible for the understanding for the mathematical learning goals. And so again, as we talk about the funneling and focusing, I don't want to plan so that it guides me in what I'm doing. I want to plan so I have options available to myself to be ready for whatever the students provide me when I'm focusing and listening to what they have to say. And so I know that the planning is never going to be complete. And that's one of the things my pre-service teachers struggle so much with, because they want to spend all of these hours they do in writing their lesson plans and getting everything and being ready for everything. And I keep trying to emphasize to them, you'll never be ready for everything. You'll hear something brand new after you've taught a lesson 10 years in a row. just because the students are bringing different ideas and different experiences. So you have to be aware of the fact that your planning is only part of what you're going to be used when you're teaching. And so you saw how the task and the questions and the evidence link together in bringing us all those different ideas and helping us think about how this task is really uncovering what my students know and where I need to take them next. Ambitious teaching requires teachers to not just use preconceived ideas, but to also incorporate in the moment decisions. I saw something on Twitter that said teachers make 1,500 decisions each and every day. All of that is in your head, and you get to figure out how you're going to use the evidence you're collecting. And a lot of that is, how am I thinking about that question that's either going to engage students together or going to tell me more about what their thinking is. And so as we've got the last couple of minutes here in our webinar, what I'd love you to do is tell me some of your takeaways from the hour that we spent together. What strategies were really helpful for you? What questions do you think will help support your students? And how do you think planning might be affected by what we've talked about? And Cindy says it what makes teaching fun. Absolutely. I get a great deal of energy from my teaching, and I love doing it. Absolutely true. And so as you're sharing those takeaways, I'm looking forward to reading them. Let me just remind you, our goals for today were to share strategies for planning effective questions, discuss questionings to meet the needs of your students, and to link those teaching outcomes to the videos that you saw, that vision of learning. So some of the takeaways, focusing more on having students verbally connect their representations with the context. And I think in doing that, you're going to build representational fluency, where students can start to work between different representations and explain where different numbers and different context pieces are in their answers and their solution strategies. Questions within the small group are really important. Getting students to confirm or argue points is important. And that's the value of that small group work, because you can have all these different discussions going on in the room. Anticipate how your students will think about problems and be ready to support them with purposeful questioning. Excellent. I love that, purposeful. Ask questions that promote student thinking. Show me how you're thinking, whether it's right or wrong. I don't tell my students whether they're right or wrong, because I want them to stay engaged in the evaluation of their own work. I like how students use the same mathematical language you did in the launch of the task. And that's important, Megan, because the language you use is the language they'll use. And I don't want to punish students for using their own language, but I'm going to continue to lay over that correct mathematical vocabulary. So I just want to say thank you very much. My name's Ed Nolan. I'm at Moravian University in Bethlehem, Pennsylvania. And there's my email. And I'm pretty sure that email is also on the handout. So if you ever have questions as you're going through this, I really hope that you email me. I love talking about math and love to talk about what you're doing. And whiteboards, I see whiteboards up there, Jonathan. They are amazing. My kids love whiteboards. My college kids love whiteboards too. I carry them around with me everywhere. Megan, you're in Bethlehem. Excellent. Awesome.
All right. Thank you very much for sharing with us, Ed. And I did post the link for the resources at the top of the chat in the little sticky note area that's blue at the top of the chat. So if you did not catch Ed's hyperlink earlier, it is up there right now in case you want to have access to the resources that he shared. So thanks once again for sharing with us, Ed, and to everyone in attendance. We thank you for joining us tonight. Our next webinar is on November 1st, and the title of the talk is Elevate Student Voices and What If Thinking with Desmos, and I'm going to be the presenter for that one. So Lena Taro, yay, that's me. So I hope some of you will be there for that session. We're going to be focusing more on a grade 8 through 12 level, so that might not be your cup of tea if you're more of an elementary educator, but I think you'd have a good time joining us anyhow. So thank you very much for joining us. Good night, everyone. And Lordy, yes.